let us continue our discussion on predicate logic. Now let us work with this UOD. Instead of set of MTech students, now it is set of students. Predicate remains the same. Active of X is active. So how do we express this statement? All students are active. This we can represent like this. First, I take an element. Now it is a student. Statement also says all students are active. Then we simply write active of X. Suppose the statement says all MTech students are active. If this is the case, then I need to define one more predicate called MTech of X, which means X is an MTech student. When you take an element from the universe of discourse, X is a student. This says X is an MTech student. This says X is active during problem session. So how do we write this? All MTech students are active. So for all X, MTech of X, so first I need to say X is an MTech student. If he is an MTech student, then he is active during problem session. So some MTech students are active. So then it is, there exists X. X is a student. First I need to say X is an MTech student and X is active. So please note, when we use existential, we use AND operator. When we use for all, we use implication operator. We will see why. If you go through the scribe, justification is given, but we shall revisit and then justify why implication operator is used for this and AND operator for there exist. Okay, suppose I say on the similar line you can write other statements as well. So none of MTech student are active. It says none of them, which means there exist an MTech student who is active is false. Correct? So how do we write this? There exists X is an MTech of X. First we say X is a student and MTech of this. That there exists a student and active. This statement is false. There exists an MTech student who is active is false. That's precisely what we have written. So what is that telling us? This and this are equivalent. How do we write this? None of the MTech students are active. You take X, and if X is an MTech student, statement says he is not active. No student is active. None of the MTech students are active. Which means for all X, MTech of X implies negation of this. And we know that this and this are equivalent. That there exists an MTech student who is active is false. And none of the MTech students are active. So these two statements are one and the same. Okay. Fine. Let's look at this statement. there exists an MTech student who is not active. There exists an MTech student who is not active. How do we write this? So there exists X. He is an MTech student and he is not active. So we see that there is a student who is not active. So how do we rewrite this statement? Not all MTech students are active. There exists a student who is not active, which means look at a class of say 7 students, all of them are not. So how do we write this for all X? MTech of X implies active of X will tell you all are active, but we say not all are active, so we get negation. And we know that this and this are equivalent. So we see that by changing the UOD and with appropriate predicate, the expression also changes. So that's very important. Given a context or a logical argument, one has to fix the UOD first and appropriate predicate, then start writing the underlying abstraction or math rotation. So according to the math, meaning the UOD and this, the notation or the expression changes. We will see whether this and this are equivalent, can we prove them, which means what? Biconditional is a tautology, or this implies this and this implies this. Both implications are tautology. We will justify that now so that you can start using this when you see them in context.